what's good, guys? Today we're going to be going over some integrals from UCSD, aka University of California, San Diego. And these are on their like extreme integrals list from like however many years ago. Some of them are hard, some of them are pretty easy. Take for example this first one, e to the x sine e to the x. It's really not that hard. You just substitute u sub, you use u sub. Um, for e to the x because you can't do sine e to the x because there's no cosine for your du, and you can't use e because it's constant, and you can't use x because it won't change anything. Substituting of like using different variables doesn't make any difference. So du, integral first, integral of du times sine u, aka just this backwards, uh, is equal to negative cosine u plus c, or once substituted u back in, it's negative cosine e to the x plus c. This is your answer. So it's just really simple u substitution for that one. This next one is a little bit more involved. Um, so looking at this, you want to use LIAT to figure out what your u is, or what, if you know that your u is going to be cosine, then you just do. Um, so like you have logarithms, inverse, like trig, algebra, normal trig, and your e's. So u, in this case, since t comes before e, and that's the only two things we have in here, your u is going to be cosine 3x is going to be a trig, which is equal to negative 3 sine 3x. Okay, and your dv is going to be your other one. Okay, so yeah, now you're going to want to use your integration by parts formula, which is uv minus integral of v du. So u times v is e to the 2x cosine 3x, excuse me, over 2 minus integral of, let's see, v, which is e to the x, e to the 2x, my bad, times du, which is, let me just, I could, yeah, let's do it like this. Negative 3 sine 3x all over 2. Okay? Now, this kind of has the same problem up here. This 2 really doesn't influence it at all because it's just a constant. Um, but yeah, it's trig times an e value, an exponential. So what we're gonna want to do is just do another thing of u sub, which I'll mark in a different color. So u is going to be, since trig is before exponential, negative sine 3x, and now du is going to be negative 9 cosine 3x. Dv is equal to, do you see how we have something divided by 2? We kind of gave the 3, to the sine, so we're going to give the 1/2 because it came from the e to back to the e. So this is that, and then this, to get this, when we have an exponent of, to get 1/2 from 2, when 2 is going to be our numerator, we need to have 1/4, because 2 up here, when we do power rule and if you take the derivative of this, it will just equal 2 times whatever is here, and 2 times 1/4 is 1/2. So that's how you work out the power rule of those. Okay, so let me let me just write this entire thing out. Was it 3x up there? Yeah. Over 2 minus, and then here we go, uv e to the 2x negative 3. I'm going to take the negative 3 and just times it by everything because you can. Makes no difference. I like having the numbers in front of e. I think it looks nicer. Over 4, obviously, minus integral of v du, which is, I know these things, they look literally the same, but this, considering u was up here, this is du. Okay. Now, let me take it even, oh, my bad. Let me take it even one step further and write out what this entire thing is equal to. A second. E to the 2x cosine 3x dx. I should have wrote dx here. I should have wrote dx for like all of these integrals that we've done. Yeah, whatever. So noting, looking at these two, like what is here? You know, what is the difference between these two? You know, they both have e to the 2x, they both have cosine x. All of the variables are kind of squared away. It's just this negative 9 times this and the whole thing being divided by 4. So essentially, with multiplication, since it's commutative and this is being multiplied by anyways, we can essentially just move this to the front. Same thing with division, since it's all being divided, we can just take it out. So we can just take out a negative 9/4 out of the integral of e. Well, now the integral is e to the 2x times cosine 3x dx, which is minus, so this is plus now. Negative 3e 2x sine 3x over 4. And then this entire thing minus, oh, my bad, e to the 2x cosine 3x over 2. Okay, so now you're thinking, okay, well this is great. Now we have this in the thing. So what do we do with this? Well, I just want to distribute this negative real fast because it's how we can't move this over to the other side unless we distribute this negative. So let me just do that real fast. E to the 2x cosine 3x over 2 plus 3x squared sine 3x over 4 plus or minus 9 over 4 integral of e to the 2x cosine 3x dx is equal to integral of e to the 2x cosine 3x dx. Okay, now we just have some basic algebra. Um, if you're like me and you like to use, instead of using these complex, they're not complex in terms of math, but like they're just fractions that might take a little bit more than a second to solve, as in like they're not 1/2, they're not 1/3, they're not 2/5. Um, I like to just like take like an extra 3 seconds and um, just convert it to you know this essentially, just convert it to a decimal. Okay, so all this stuff just comes down. We're not messing with that right now. All we care about right now is this integral. So to avoid having to rewrite this, I'm just going to do that. You wouldn't want to do this on a test, unless your teacher, says that you can. But especially on an AP like FRQ, you wouldn't want to do that because they might not know what you mean, and then you get a question wrong for some stupid reason. So this is just basic algebra. You can treat these kind of treat these integrals like say that this is like some variable like z. It's like what do we have here? Well, clearly here we have 1z, but here since there's negative 2.5, we have negative 2.25z in a way, if that makes sense. And then you just do basic algebra and you just move it over. So you just add the coefficients here. So this is equal to uh what's this, 3.25? Yeah, obviously negative 2 point, or it's gonna be added. So yeah, 3.25 e to the 2x cosine 3x dx is equal to e to the 2x cosine x over 2 plus 3 to the 2x sine 3x. This should be 3x, my bad, over 4. Um, so yeah. So now we're going to just gonna add these to make them under the same thing so that we can just straight up divide this away. Because if we divide it away right now, it's gonna be like this entire thing, and then we have to find a thing here, and it's pretty easy because it's just 2 and 4. So we're gonna times this entire thing by 2 and times this entire thing by 1, obviously. So this is just gonna equal 2e to the 2x cosine 3. Okay, cosine 3x over 4 plus 3 uh, e2x sine 3x over 4. Nope, not. They're not two different things. My bad. Plus 3e 2x sine 3x. There is equal to, and then this integral. Okay, so we want to find what just this integral alone is. This integral up here is alone. We don't want to find what it is multiplied by 3.25. So since it's being multiplied, the way that we get rid of it to the other side by algebra rules is to divide. So since we're dividing, we don't have to do anything with this top at all. We just push it straight to the bottom, and we multiply it with the already there denominator. So it's gonna be 2e to the 2x cosine 3x. I promise we're almost done. 3e to the 2x sine 3x over 4 times 3.25. This is equal to 13. This denominator thing is equal to 13. So your answer, um, I'm pretty sure that just writing it like 4 times 3.25 equals and then the integral is technically correct as well because it's a true statement. So 2e to the 2x cosine 3x plus 3e 2x sine 3x over 13 uh, is equal to, don't forget your plus c, uh, is equal to your integral of e to the 2x cosine 3x dx. This in red is your answer. So two things of integration by parts, and then moving integrals across, and well, simplifying, and then moving integrals across, and then finding common denominators, and then finally moving algebra over and dividing and getting your answer. So yeah, that was a pretty complex problem, but luckily most of the steps are pretty easy. There was just a lot of them. So hope you enjoyed.